Assalamualaikum and good day. So we are from Group C. We'll presenting about our lab report about experiment 1 Marcet Boiler. We will start with introduction. Thermodynamics deal with the relation of heat, work, and energy which that contains units such as entropy and enthalpy. The evaluation of thermodynamics towards a system is to determine whether to see the system could perform useful works to the surroundings or not. In the context of heat, two important thermodynamic properties, which are temperature and pressure, brings a huge impact towards heat generated or released. These two factors also can be correlated with each other, such temperature will increase if pressure is increased. This relation can be further observed in this experiment. Next, we move on to the objective of this experiment. The objective of this experiment is to observe the relationship between the pressure and temperature for saturated steam. After that, we move on to the theory that will be used in this experiment. The Marcet boiler was used to investigate the relationship between the pressure and temperature of water between the pressure ranging from 0 to 5 bar. The temperature of the Marcet boiler should be increasing linearly with the increasing of pressure. The relation between temperature and pressure is directly proportional. The ideal gas law equation can be related to the pressure, temperature, and volume of an ideal gas. An ideal gas is when the condition of the gas satisfy the condition where pressure, volume, and temperature is constant. The data from the experiment can also be related with Clapeyron equation. The Clapeyron equation can be used to relate between pressure and temperature of a saturated steam in equilibrium. The first equation on the top left is the ideal gas law equation, and the second equation on the bottom left is the Clapeyron equation.
And for the experiment setup, we have the Marcet boiler, including first safety valve on the top of the Marcet boiler, second is the boiler, third is pressure gauge, four switch cabinet with temperature display, five drain valve, six heater, seven overflow valve, and eight the temperature sensor. And for the procedure, first we have to fill the boiler with the water when the filter plug is open. Second, the excess water is flowed out through the outlet valve when the boiler is full. Third, filter plug is closed. Fourth, main and heater switch is switched on. And five, water is heated in the boiler until it reaches 60 degrees Celsius. Next, number 6, the increase in temperature for each pressure of 0.5 bar until the pressure reaches 5 bars were recorded. 7, heater switch is off and the decrease in temperature for each pressure of 0.5 bar was recorded. Number 8, the results were recorded and the main switch is off. And lastly, is the equipment was in good condition as before the equipment was used. Safety precaution for this experiment is including the spanner is used to open and close the filter plug only. When the distilled water is poured into the boiler, a filter funnel is used to prevent water spill. And lastly, gloves were provided to handle the experiment due to the high level of temperature of the Marcet boiler.
Next, we will move on to the calculation. As for the absolute pressure, add the atmospheric pressure, which is 1 bar, to the gauge pressure. And then for the mean temperature, for example at 1.5 bar, add the increasing temperature with the decreasing temperature and then divided it by 2. Then for the difference of temperature, for example at 2 bar, Just subtract the temperature at 2 bar with the temperature at previous pressure. Before that, we must convert the temperature to Kelvin by adding 273.15. Next, for the difference of pressure, for example at 2 bar, subtract the pressure at 2 bar with pressure at 1.5 bar and then convert it to kilopascal. Then, for the measured slope, for example at 2 bar, divide the result of difference of temperature with the difference of pressure. And lastly, for the calculated slope, times the mean temperature in Kelvin with its specific volume and then divided it with its enthalpy.
Next, let me explain about graph that we plot for this experiment. Graph 1 indicate the relationship between absolute pressure and temperature for the heating process. The experiment results show a linear relationship which indicate that the absolute pressure and temperature are directly proportional to one another while maintaining the constant volume. Next, graph 2 indicate the relationship between the absolute pressure and temperature for the cooling process. The experiment results show a linear relationship which indicate that the absolute pressure and temperature are directly proportional to one another while maintaining the volume constant. The temperature was seen to increase during the early cooling phase even though the heating mechanism was turned off. However, the graph above show that the temperature is decreasing while the absolute pressure is decreasing. This can be concluded that the absolute pressure and the temperature depend on each other. Next, we moving on to the third graph. Graph 3 demonstrates the relationship between absolute pressure and mean temperature which focus on the temperature difference between the cooling and heating process. The trend shown in the graph shows that temperature increase with rising pressure and lower with lowering pressure, much like the aforementioned graph. Based on the graph shown, the blue dot represent the measured slope and the red dot represent the calculated slope. Graph 4 demonstrate the relationship between absolute pressure against measured and calculated slope. The graph also show the comparison of the value of measured slope and calculated slope. It is shown that there are huge difference and deviation from the data collected. Absolute pressure versus calculated slope illustrate a decreasing trend line pattern. However, absolute pressure versus measured slope illustrate a random pattern that deviates significantly from the expected pattern due to the malfunctioning equipment used to gather the experiment's data. Next, we moving on to the discussion part. This experiment one investigate the relationship between pressure and temperature of saturated steam using Marcet Boiler for the heating and cooling process. It is crucial to take safety precaution. It is crucial to first completely empty the boiler of air before starting the experiment in order to prevent air from influencing the result. The accurate equilibrium measurement between steam and boiling water cannot be achieved if the air is not eliminated. Furthermore, the trapped air may cause the boiler to malfunction. During the experiment, when the liquid water reaches a high enough temperature, the water molecules inside the boiler start to absorb heat and move more swiftly. The water molecules start to travel apart and transform into gas because they were traveling so fast that they could not even hold on to one another. The liquid becomes vapor once enough heat energy has been gathered. However, the steam was trapped, the boiler's internal pressure rose, raising the boiler temperature in the process. Steam is created when liquid turns into gas and evaporated. Based on the result obtained, it shows that the relationship between absolute pressure and the temperature as shown in graph 1 and graph 2. Based on graph 1 and graph 2, we can conclude that the absolute pressure and temperature are directly proportional to one another. As the temperature increases, the absolute pressure also increases. Next, we have reached the last part of this lab report, which is the conclusion. The experiment results in the conclusion that the temperature and pressure have a linear relationship, whereby the value of temperature increase and decrease linearly with pressure after translating the data into their corresponding graphical representation. It is clear that steam pressure and temperature are independent.
Unfortunately, the value of calculated slope and measured slope had a different value. This difference may be made by malfunctioning equipment, and the data collection procedure throughout the experiment are to blame for the discrepancy between the estimate and observed slope.